Hello, my name is Casey Pitcher, and this is my presentation for conducting a correlational analysis. Our agenda is going to be looking at an overview of what a correlation analysis is. Then we are looking at 6 scenarios where we found a significant relationship, and then we will be looking at takeaways. So a correlation analysis, correlation is a single number that represents the relationship between two variables. So a correlation analysis is conducted to understand what the relationship is between the variables. The following slides will show the significant correlation between the 6 sets of data. So the first test is income and savings. The null hypothesis is there is no correlation between income and savings. So the alternative hypothesis is that there is a correlation between income and savings. So after conducting the test using PSPP, assuming alpha is 0.05, we found that there is a significant correlation with the R value being 0.91 and the P value being 0.0. Therefore, we can reject the null hypothesis and conclude that there is a correlation between the amount of income and savings. The second one that we did is income and stocks. Again, our null hypothesis is there is no correlation between income and stocks. Our alternative is there is a correlation between income and stocks. So again, using PSPP, assuming alpha is 0.05, we were able to find that there is a significant correlation with R value being 0.19 and P value being 0.018. Therefore, we can reject the null and conclude there is a correlation between the amount of income and stocks. Although in this case, it's a very weak, nonetheless, it is still a correlation. Income and wallets is the next one. The original null hypothesis is there is no correlation between income and wallets. The alternative being there is a correlation between income and wallets. Once again, we calculated using PSPP, assuming alpha is 0.05, and we found that there is a perfect correlation with R value being 1 and P value being 0.0. There is a correlation. Again, a perfect correlation between the amount of income and wallets in this scenario. So the next one is savings and stocks. The null hypothesis is there is no correlation between savings and stocks. The alternative is that there is a correlation between savings and stocks. Again, using PSPP to calculate, assuming alpha is 0.05, a significant correlation did emerge with R value being 0.28 and P value being 0.00. Therefore, we can reject the null hypothesis and conclude that there is a correlation between the amount of savings and stocks. Savings and wallet. The null hypothesis is there is no correlation between savings and wallet. The alternative being that there is a correlation between savings and wallet. Using PSPP, assuming alpha is 0.05, a significant correlation did emerge with R value being 0.91, P value being 0.00. Therefore, we were able to reject the null hypothesis and conclude that there is a correlation between the amount of savings and wallets. The last one is stocks and wallet. The null hypothesis is there is no correlation between income and wallets. The alternative is that there is a correlation between income and wallets. After conducting our test, we were able to conclude that there is a correlation with the R value being 0.19 and p-value being 0.017. Therefore, we can reject the null hypothesis and conclude there is a correlation between the amount of stocks and wallets. Some key takeaways to take is PSPP is a quick and very easy tool to use for data analysis. Correlation testing can be used for determining whether variables are statistically significant, the strength of the relationship, and whether that relationship is positive, negative, or just non-existing. Thank you for listening. If you have any questions, feel free to reach out to me.